Okay, hello. I'm very happy to be here again after I think 5, 6, 7, 8 years time where I could not be at the SpectroNet Conference. My name is Oliver Barz. I'm working in the machine vision industry for more than 20 years, and 1.5 years ago I joined JAI and now want to introduce our prism cameras and of course the benefits of these prism cameras. So this is more or less what I will talk about. It's more for the paperwork that you can most likely download later on. Let's directly start. And we are all talking about wavelengths, color, whatsoever, depending on who's talking. So this is very good that the beamer is not as good as the screen over here. So this is taken with a regular single sensor camera, and you can see that there are slight deviations between all that lasers. But with a prism camera, you can get a much better result in the color separation of these different types. And I will now show you why. So the big benefit is, I assume you all know how a single sensor bi-pattern camera works, so I don't want to explain it again. We go a different way. So we use the white light coming in from the lens through a prism, and we separate the colors without any loss. In these bi-patterns, you lose around 2/3 of the light because you're filtering away most of your light. So we split the light and we use the blue waveband going down here, the red waveband going up here, and the remaining part, the green light, goes to a third sensor. So we collect all the light on 3 different sensors. We know the waveband, so we can call this, of course, monochromatic sensor, a blue sensor, because we know it's only blue light coming in, and with the other sensors accordingly. In a single sensor, you have to interpolate your colors. So you lose resolution, and of course you also lose color information, because the split done in the bi-pattern has a vast overlap between the bands. Here, with a prism, I said we split the blue light from red and green light, so we have a very steep edge and only a very small crosstalk. So that gives us what I showed in the beginning, a much better color separation between the 2 camera technologies. Another challenge that we frequently see in machine vision applications, and that's my world where I'm coming from, is that even though you might be able to use filtered pixels which give you the full resolution. So here in typical quad line scan cameras, you have one line with red filters on top, the other line with green, and so on filters. But these are, of course, on different positions. So you look for the same time to different positions on your, for example, conveyor belt, on your object. This means as long as the object is not perfectly fixed, and the encoder of the conveyor belt is not working very exact, you might not get the right color information matched to the same pixel in processing. While with the prism technology, of course, we have a single optical path. We combine the image up here in the prism, or we split the image to be more correct, and we look to a single point. And this is a big benefit, especially if we look to fruit and vegetables. They move on the conveyor belt slightly, and many of our customers are quite happy that we are still making these prism cameras, where many people say, oh, we have 50 megapixel cameras with a high resolution, much higher than any prism camera, but there are still other benefits to see. So especially we don't see random changes in the object moving by vibration or whatsoever. And of course, with a line scan camera, we can even combine 4 channels. So we can add a near-infrared channel to red, green, and blue as well. it becomes even more complicated if the objects are free falling. Yeah? For example, like here. So yeah, please sort this. I know the ISP is quite good in this. I think to remember they might use our cameras. So with a single optical path, you get the same color information from the same position in time and in space. While with these type of cameras, you need to determine, to interpolate, to assume where your object might have moved in, of course, only a short period of time, but still some time. And then we can add, as I said before, the near-infrared channel and get new insights. And I can show you this over here. So I brought a few cameras, of course matrix cameras, to make it a little bit more easy for me. But in the breaks I can show you what I mean in more detail. And the near-infrared brings us benefits. I think I might not need to tell you, but this is a general presentation introducing these cameras. So I have a slide here with a color image, and that already looks quite nice. But when you change the waveband, you see that someone has spilled water on it. And I don't think that you want to sell this cookie. So again, the technology behind is using a prism to split the light. In that case, not between red, green, and blue, but between visible and near-infrared, or even two near-infrared channels. And this is, for example, used in getting rid of rubbish, which comes from the field. As we saw in the beginning talks already, we sometimes have to sort rubbish out of what we want to have. And looking only to the visible, we see that some reference rubbish objects look pretty much the same, but introducing a near-infrared channel, which is in that case shown in green, gives you a very good contrast to sort. Or going to the color space diagram, you see this is a rubbish, and this is what we want to have. Also, we can use different wavebands to gather different information in a single image. For example, illuminating in white to see the front side, to see the label of the package, and use, of course, a very strong near-infrared lighting to see what's inside. And this technology becomes even better moving to shortwave infrared, where we have a wider separation of the wavebands. And doing this simultaneously ensures that the information gathered is exactly from the same position. So sometimes that's very important to know, yes, that did not change. I remember from 25 years ago, we used a lot more paper than today. And for some documents, it was mandatory to have the front side and the back side within the same image, which was done with a very complicated system of mirrors to ensure that both sides were imaged to the same sensor in a single image. But now I have an image I pretty much like, because the task is to just grab the fruits from the tree. Yeah, please help me. How many fruits do you think are in there? Let's change the waveband. And here we use specific wavebands, carefully selected. We limit the color information getting to the sensor with some bandpass filters. And now we can segment our fruits, our green fruits from the green tree. Yeah, and the rest is just algorithms. Yeah, but would you have expected getting so much fruit from the first image? And the key is to use the standard information only in limited bands. So what we do is we of course use our prism camera. So this is a camera using a visible band and two near-infrared bands. And then we can apply specific filters between the output of the prism and the intake of the sensor. and limit the information that we get through the filter with some, of course, technical requirements like a minimum of 25 nanometers bandwidth, and of course we not better than 5 nanometers in positioning the filters, which is more or less a cost question. So, but we are not the filter specialists, we are the prism camera specialists. So that in the end gives you a limited waveband information, ensuring that you get all the information you need. And then the camera is mounted to a very tricky outdoor truck, which I pretty much like because it shows that this is a technology which you can use also in environments where it's vibrating, where you have shocks to the camera. Nothing happens. The prism block and the sensors are assembled together in a very tight way, so nothing happens. And another application where you carefully need to select your wavebands is medical imaging, because you typically want to use a fluorescence marker to, for example, find a tumor, and the resulting image is very faint. Oh yes, yeah. But using different sensors, you can use different exposure times, so you can enhance the image quality and just illuminate this image properly and illuminate this image properly, and then have an overlay as a result, giving you an image that the was ist Chirurg auf English? The surgeon can use to cut away only the tumor. Okay, that's all for now.